In this lesson, we are going to learn about the identity matrix. The identity matrix, denoted by the symbol I sub n, is an n by n matrix which has n rows and n columns. Okay, so the n there tells the number of rows. And then it also tells the number of what? Columns. So in this case, if you have an identity matrix with n, okay, that is going to be an n by n matrix. Okay, so the n here tells the number of rows and then the number of what? Columns. And since you're having an n by n matrix here, which means that the number of rows equals or the number of columns, then you are going to have what? A square matrix. So this tells us that an identity matrix is a square matrix. Let's look at an example. So I have an identity matrix with the n value to be 2. Okay, so this will be 1 0 0 1. Okay, so this is how to write the identity matrix when the n is equal to what? 2. Okay, so for the identity matrix, okay, the entries on the diagonal from the upper left to the bottom right are all ones. Okay, so the entries on the diagonal from the upper left to the bottom right are all ones. So let's look at this. So these are the entries, okay, on the diagonal from the upper left to the bottom right, and then you see that they are all 1, and then the remaining entries will be what? 0. So for identity matrix, all you have to focus on is the entries on the diagonal, okay, from the upper left to the bottom right. They must all be what? 1s, and then the other entries must be what? 0s. Let's look at another example. So let's say I have an identity matrix with n value to be 3. Okay, so I'm going to have 1 0 0 0 1 0 0 0 1. So in this case, looking at the diagonals, okay, looking at the entries on the diagonal from the upper left, okay, to the bottom right, we have 1s in there. Okay, so we have these values here. You see that they are all 1s. Okay, so the entries from the upper left, okay, to the bottom right on the diagonal must all be 1s, and then the remaining entries must be what? 0. Okay, so same way, if I have I sub 4, I'm going to have 1 0 0 0, and then 0 1 0 0, and then I have 0 0 1 0, and I'll have what? 0 0 0 1. So you see that all the entries on the diagonal, okay, from the upper left, okay, to the bottom right are all 1s, right? All the entries on the diagonal from the upper left to the bottom right are all 1s, and then the remaining entries are 0. So that's what an identity matrix is. So if n equals 4, then you're going to have a 4 by 4 identity matrix. If n equals 2, then you're going to have a 2 by 2 identity matrix. So let's take note of this. Okay, so now let's continue. So let's look at something here. Let's say if I have a matrix A, okay, if I have a matrix A, and then I multiply this matrix A here, okay, by the identity matrix, I'll get the same matrix A. So that'll be the matrix A multiplied by the identity, okay, will give me the matrix A again. Okay, when I multiply a matrix A with its identity matrix, I'll get a matrix again. Similarly, when I multiply the matrix A, okay, by its inverse, okay, I'm going to get the identity of that matrix A. Okay, I'm going to get what? The identity of what? That matrix A. Okay, so the identity matrix plays the same rules as the number one in real numbers. Okay, the identity matrix plays the same rule as what? The number one in real numbers. Let's look at what that means. So in real numbers, I know that if I have a number, say 6, okay, and then I multiply it what? By 1, I'm going to get what? 6, right? And then let's say I have a number 6. Okay, the inverse of number 6 will be 1 over 6, right? Or 6 to the power minus 1, right? When I multiply this inverse by 6, I'm going to get 1, right? So that will be 6 times 1 over 6. That will give me a value of what? 1. Okay, so it's the same thing that's happening to the identity matrix. Okay, so when I multiply a matrix A by the identity, I'm going to get what? The matrix A again. Okay, similarly, when I multiply 6 by 1, we are going to get 6 again. Same thing here. When I multiply a matrix A by its inverse, I'm going to get the what? I'm going to get the identity. Same way, when I multiply the number 6 by its inverse, I'm going to get 1. So the 1 here, okay, and the identity are similar. Okay, the 1 and then the identity are similar, but the identity matrix is used in the case of what? Matrices, and then the 1 is used in the case of what? Real numbers. Okay, so those are the similarities between the identity matrix and then the number 1. Okay, so let's take note of this.